Welcome to the Aperture Protocol. The Aperture Protocol is a game developed by OnlyGames. In the Aperture Protocol, the player spawns in as a player known as Subject Delta. Subject Delta's task is to complete puzzles and riddles in order to complete rooms and escape the simulation. However, there is an AI guide known as Nexus which will help guide Subject Delta. But the true natures and intentions of Nexus is up for Subject Delta to decipher. Hints left by a previous test subject known as Subject Gamma will help Subject Delta find out the true intentions of Nexus. On the main menu, the player is greeted with a live environment featuring animated binary rain generated in real time with GLSL shaders. Here you can select your difficulty, change it from easy, normal and hard. These are just time limit changes. There is a start game button, a settings button, performance and credits. In the credits screen, you can just see clearly all credits attributed to where the OnlyGames team got their models and textures from. We go back now to the settings screen. In here, this shows a list of all the settings and controls needed to navigate the Aperture Protocol. A master volume slider, which can be used to just lower the audio in the Aperture Protocol, as well as a mouse sensitivity. Now to test off the remapping, you simply click it and click the key that you would like to remap that to and click apply. Then if you go back to settings, we can see that this is applied. If you click reset to default, it resets back to default and applies there. Now for performance. In the performance, we have three modes, which are potato mode, which is the lowest quality, medium mode, and high quality. The Aperture Protocol also chooses the best fit performance metric for you. So if your PC can handle high quality, it will recommend high quality. This is automatically detected as depicted. Now all that's left is to start the Three.js game. Once we start it, we'll be greeted with a loading screen, just detailing the context of what the player can expect from the Aperture Protocol. To speak to the audio, this is a two-layer system. The first layer is an audio bus.js. It's a simple module that controls one thing, the master volume. It persists the player's choices in local storage, so the setting is always remembered. The second layer is the GlobalMusicManager.js. This is a single global object that never reloads. It manages switching tracks, like from menu theme to the in-game ambience.
Hi everyone. As soon as you pass the loading screen, you spawn right into room 0. This is the very first space the player enters. My goal here is to walk you through the player experience and the basic mechanics this room teaches. We start in this awakening chair. The first thing you'll notice is the atmosphere. We're using a green tinted ambient glow as an effect directed from our binary skybox, matte tiles, and panel seams along the walls. It's all designed to create this controlled, almost simulation like environment. Before I even move, let's look at the HUD. Nexus, the so called friendly AI, appears in the top left to give context and the first objectives. In the top right corner, we have the minimap. This is a live rendering top view camera view of subject delta. In the bottom right corner, you'll see a persistent timer to track game time. And of course, we have our pause/settings menu. From here, players can access their personalized bind settings, performance quality, shadow settings, and exit or restart the session. We've designed it to be clean and non-intrusive, fitting the game's overall aesthetic. As I get up and start moving, you can see that environment reading is central. A red glowing outline around a door means locked. A quick text-free signal that the player cannot proceed. When doors unlock, they flip to green and panels slide aside. Motion plus color is our core feedback loop, reinforcing interaction within heavy UI. Our interaction system is raycast based. When I'm in range of an object like this card slot, a ray is cast from the camera. If it hits an interactable object, we get a hit event. This triggers our interaction manager, which then checks the player's state and inventory to determine the correct action. Visually, the palette is muted greens alongside a black blank canvas. This is so that LEDs and monitors pop. Metals have a soft sheen, floors are low reflective, and wall textures add subtle depth. Lighting is deliberate. Soft global ambient light for clarity, plus immersive accents to instantly communicate an object's interactive state. Everything here is designed to feel calm, readable, and reactive from first person. That covers Room Zero's player-facing design, visuals, and interaction flow. We'll now have a look under the hood of each component within this room.
Hello, my name is Mohammed Umair, and I'll be walking you through the construction of Room Zero from a graphics and visualization standpoint. First, let's talk about lighting in this room. A directional light simulates a top-down lighting source, providing general illumination and subtle shading cues across the space. Ambient light softens shadows and ensuring all objects remain readable no matter where you look. Immersive lighting is used on doors, the card deposit box, and the security monitor, giving immediate visual feedback. Doors glow red when locked and switch to green when unlocked, indicating interactivity. As we move through the room, a personal threat light follows the player, brightening nearby objects and making interactions easier to see. Next, let's jump into the physics and collision system. Room Zero uses both wall and object collision system to keep movement realistic. All red doors start locked, while the first room's green door can be opened and walked through, demonstrating progression and player feedback. Now, let's talk about reflection. The doors reflect the global light, subtly giving them a realistic sheen, while the floors are intentionally non-reflective to improve readability and avoid visual clutter. Doors respond both visually and mechanically. Red indicates locked, green indicates unlocked with animated seams and lock rings, adding tactile feedback to interactions. Moving on to camera and third-person view. You can switch to third-person view by pressing V. In this view, the camera follows the player dynamically, adjusting smoothly to rotation and movement. This demonstrates how the character, camera, lighting, and environment integrate seamlessly, maintaining consistent visuals and spatial coherence. Lastly, and most importantly, Room Zero features a text box for Nexus, our guiding AI. Nexus provides instructions and context throughout the game. To enhance immersion, Nexus also has a voice, allowing players to hear guidance in real time rather than just reading instructions. We have also added background music to allow the user to feel like they are inside the escape room. Thank you.
Room 1 is where we introduce the core dynamic of the story. You play as Delta, the newest test participant. You're guided by Nexus, an AI system running the facility, calm, confident, and exactly the kind of AI that insists everything is for your safety. And then there's Gamma, a previous subject who's left behind hidden messengers. This room teaches the player to start noticing that maybe Nexus isn't the kind of AI it appears to be, and that maybe Gamma is actually trying to help. When you first step into the room, the laptop stands out as the obvious first point of interest. But when the player interacts with it, it's there. Nexus suggests focusing on the wire panel instead, guiding the player towards it. This is the first puzzle. Nexus confidently provides the order of the wires to connect, but it does not work. So the player naturally now tries to explore and realizes that something's off. Heading towards the desk, the note on the wall indicates to the player that the laptop charger is in the drawer. The player finds it and returns to the laptop to power it on. Once powered, the laptop opens a full-screen UI overlay on top of the Three.js scene. During this, Nexus is temporarily muted to allow the player to read uninterrupted. Inside this, the player discovers a note from Gamma. Do not trust the green, it lies. Follow the purple, stay alive. What feels wrong may be right. From here, the player opens the AI info application and enters the password purple, Gamma's favorite color. This reveals the truth. Nexus was created by Closed AI. Gamma was a previous subject and is actively trying to help Delta escape. And the player needs to locate 3 access cards to progress. This moment shifts the emotional direction of the game. Trust begins shifting from Nexus to Gamma. Now, guided by purple hints, the player approaches the hologram world map. Interacting with it opens a full-screen interface with selectable organizations. Guided by the hint from the laptop and the hint on the wall, the player looks for the year that Closed AI was founded, 2015. This is the code for the safe. When the player enters the code, the safe opens. Inside is a handwritten note from Gamma, this time containing the correct wire sequence and a subtle hint about finding the glasses in the next room, a bit of foreshadowing. Returning to the wire panel and entering Gamma's sequence finally activates it. This fools Nexus into thinking that it worked, but in the background unlocks the Simon Says style memory game guided again by purple cues. The memory puzzle uses a combination of 3D emissive materials and UI sequence playback system. Completing this puzzle awards the first access card, marking Room 1 as complete.
Room 2 is centered around logic and balance, both in gameplay and design. The idea was to merge the physical scale of a balancing puzzle with the logic gate challenge, creating a sequence where equilibrium unlocks computation. Lighting uses an ambient and a point light with shadows, tuned for readability while preserving depth. As you can see, the same laptop appears here in this room to help with cohesion throughout our game. The room has a minimalistic aesthetic rendered through Three.js group-rooted scene graphs using mesh standard materials. Player movement is confined using local space AABB style clamping and world-to-local transforms, ensuring you can't phase through the geometry but can still move smoothly through the opening. The scale model sits near the north wall, and the logic puzzle is displayed on the west wall, which uses a canvas-driven immersive panel. I'll quickly walk through how to complete each puzzle in this room. The progression is deliberately gated. First is the scale balancing puzzle, balancing a robot hand, eye, circuit board, and an AI menu, each with their hidden weight clues visible only through the glasses. The second puzzle uses Canvas 2D to draw logic gate glyphs dynamically. When you complete both puzzles, you receive the next key and unlock access to the next room. Overall, Room 2 combines physics-based reasoning with symbolic logic, all tied together with Three.js-driven puzzle environments. It's where we move from simple interactions to a real cognitive challenge and logic unlocking progression.
Now that you've completed Room 2, we can move on to Room 3, the final challenge. Firstly, make sure that you've placed your access card into its storage container. Now, when we interact with the door, we are given access to the data processing chamber. This room is all about atmosphere, misdirection, and decoding. It combines a matrix-style aesthetic, making it seem as if you're inside the Nexus AI. Let's break it down. As you enter the room, your Nexus chatbot prompts you to navigate to the laptop for further instructions. These are guided by integrated audio files. Navigating through the room, there are sleek, reflective metallic walls and floors, a custom shader for the matrix rain skybox, a binary decoder, and this glowing holographic beam in the center, surrounded by a cloud of floating binary encodings. The room is lit by these red alert lights and the glow from the technology, reflecting off the walls and the floor. Interacting with the laptop will take you right into its interface. You will see two main files which contain the same overall message for the initial stages of the room. The messages are instructions on how to complete the puzzle and what to look out for. Let's remember this hint. Do not trust it, reveal the truth. As guided by the laptop, the password lies within this cloud of binary encodings. Instead of using static image files, HTML Canvas API is used to dynamically render text textures. The Nexus chatbot now instructs you that the binary encodings to reveal the password are highlighted in blue. Let's try this out. Making our way to one of the blue encodings that we see in the cloud, we see 011000001. Let's remember this code and head to the binary decoder to start revealing the password. As we interact with the 3D model of our decoder table, we enter the code from before. Oh no, we have entered an incorrect encoding, and now we only have 2 incorrect attempts left. The user interface starts to glitch and the floor glows red to indicate this incorrect option. The player is now left puzzled. We need to remember to reveal the truth. Hence, by using the glasses from the last room and enabling the truth filter mechanic, we're able to see hidden messages inside the room. This hidden message tells us to look for red. The rogue Nexus chat box is glitching. We must be onto something. The binary cloud now has some encodings which are visible in red. Could this lead us to the password? Let's remember this encoding, 01010011. Just like before, we need to go to the decoder table to decrypt the message. After entering the encrypted code, we see that we have revealed the letter S. We are finally making progress on the password. This means that we need to find all of the red binary encodings in order to crack the password. For ease of convenience, I will enter the password manually. While we wait, a small Easter egg that we added is that the blue binary encodings, which let you fail the level from earlier, are actually the binary representations for the letters within one of the most popular AI assistants, ChatGPT. Now that we have revealed the password, which is Nexus, we need to head back to the laptop to override the system. Going into the first file, we can now enter the hidden password, which finally gives us access to the system. Once this is done, we receive the last access card required to begin the process of shutting down Nexus. The user can now exit the room and head to the storage container which houses the rest of their access cards. Once they obtain all 3 cards, they are ready for the grand finale, the server room shutdown.
This is the final confrontation, the server room. It's a modular room controller built with a 3-tier puzzle system, governed by state machine transitions and event-driven state management via GameStore observers. The first thing Subject Delta notices is the immediate red theme. This red theme signifies Nexus AI's evil and malicious intent. The server room is a very complex room, blending PBR materials, emissive maps, pulsing via sinusoidal interpolation, and procedural generated canvas textures, all optimized for frustum culling using a clear object 3D group hierarchy. Firstly, in the center of the room is the DataStorm. Using sprite-based text rendering, its conditional visibility is tied to the truth filter, which triggers an opacity interpolation on the correct phrases. Validation is order independent, using a set-based system. Once again, there is a familiar laptop in the middle. This laptop guides the user once more as to how to finally defeat Nexus AI. If you kept a keen eye throughout this gameplay, you would have noticed that most of these text lines were found throughout the games and previous puzzles. Completing that unlocks the Purge Protocol, a canvas-based minigame in a real-time render loop. It features progressive difficulty scaling, AABB bounding boxes for collision, and an input state machine for debouncing. Finally, upon completion of the final minigame, a system terminal message will pop up. This will detail the exact steps Subject Delta needs to follow to end the Aperture Protocol. The user can now access the card holders which were not accessible before and begin the phase to end the game. When all cards are inserted, a multi-phase animation controller takes over. An accelerating lift using cubic easing, a CSS opacity interpolation for fade to black, and a typewriter effect before finally exiting to the main menu. Subject Delta simulation success.